So, of all the carbon dioxide that we as humans are pumping into our atmosphere, only 55% of it is actually being taken out via natural processes. Why is that though? Well, it all has to do with timescales. So, what we're going to be talking about in this video and the next two videos are the different timescales of carbon cycles. This video is dedicated to the short-term carbon cycle, and you're going to see some familiar stuff here, but it's still worth talking about. So, short-term carbon cycles are carbon cycles that are relatively quickly. Photosynthesis, for example, the process of taking carbon dioxide and water, throwing in some sunlight, a few other things are involved as well, some nutrients, some nitrogen, and so on, but we're not going to worry about that. On the other end, what comes out is sugar and oxygen. Plants use that sugar for food. Animals eat that sugar. We eat that sugar. And then we also breathe in the oxygen. So that is the photosynthesis cycle. And that process is actually happening pretty ongoing. Plants are doing that on a pretty regular basis. That's why plants grow. That's why you see blooming in the springtime, because photosynthetic activity is happening on a regular, pretty quickly basis. So it's a pretty short-term process. Meanwhile, when you get up every day, you gotta eat or consume something. I have my Starbucks coffee with 2 pumps of mocha right here. And a part of what we eat is sugar. Not just the bad sugar that everybody says you're not supposed to eat, but there's also other types of sugars that are actually very, very valuable and very necessary for bodily functions. And we consume those. And we also breathe in oxygen. So the byproducts of photosynthesis, namely sugar and oxygen, are then consumed by animals and other organisms. And then on the other way out comes carbon dioxide, water vapor, and then energy. And that energy is what runs our everyday lives. I mean, if you feel heat coming off your body, that's because energy is being released in that process. So basically, photosynthesis is a way of taking solar energy and storing it in sugar. And then what we do by consuming that sugar, we actually convert that energy back out into energy that fuels our everyday lives. So right now, even me talking, my body is actually using energy that I have consumed by eating sugars and by eating proteins and fats and so on. And on the other end, I'm also breathing out carbon dioxide, and there's actually water vapor in my breath. Don't believe me? Next time it's really cold, go outside and what you actually see coming out, that's actually water vapor. So this is a very, very well-known cycle. Now, that being said, this cycle, or the rates at which these cycles are happening, are actually changing throughout the year. When you get into the spring and summer months, plants are waking up. They are performing more photosynthesis. Therefore, photosynthesis now becomes greater than respiration. And that causes carbon dioxide in the atmosphere, the total amount, to decline. Then you get into fall. Fall comes around. The days become shorter. You grab your pumpkin spice latte, you put on your brown boots, and you go out and you take pictures and put them on Instagram of all the leaves on the ground. Well, what's happening there is those same trees that were doing all that photosynthesis are now going to sleep. They're hibernating. And so the amount of photosynthetic activity now becomes less than the amount of respiration, and that causes carbon dioxide concentrations to go up. So we actually see these effects as balancing act between photosynthesis and respiration in the keeling curve. We actually see it in the keeling curve. Increases in the fall and winter time, decreases in the spring and summer, increases again in the fall and winter, decreases again in the spring and summer. Um, that's one of the reasons why the keeling curve looks spiky, or as I like to say, it looks like Bart Simpson's hair. So that is an example of a short-term cycle. That is a relatively short-term process. We see that on a daily basis. We experience it when we breathe out carbon dioxide. Every plant around us is actually taking in that carbon dioxide. That is a short-term process. That is a short-term process. And so this just kind of details that a little bit. This just kind of details that a little bit. Now, here's the thing. If humans weren't even here, this process would still occur. Why? Because plants themselves also respire. Not just humans. Other animals respire as well, but plants themselves respire. Those cute, crunchy orange leaves that you took the picture of on the ground and posted on your Instagram, those are actually leaves that are full of carbon, that have fallen off the tree, and that actually decay over time. And that decay actually adds carbon back into the atmosphere. So even without humans, this cycle would actually still be well pronounced. If humans were to go away, we would still see this up and down cycle happening on an annual basis. So during spring and summer, carbon dioxide levels go down. During fall and winter, carbon dioxide levels go up. They go up. So other examples of the short-term carbon cycle also include things like soils. A lot of things that die end up actually getting absorbed into soil and become a part of the soil. So there's an old statement that from the ground you came and from the ground you shall return. When things die, they end up getting reabsorbed back into the soil. That's what's going on there. There's actually a lot of decay that happens from bacteria that then releases the carbon back into the atmosphere. And then our surface oceans themselves also actually absorb and release carbon dioxide via photosynthetic activity from phytoplankton and from outgassing from the ocean itself. So these are other components of the short-term cycle. Now, that being said, there's one other short-term carbon process that I want to talk about right now: the burning of fossil fuels. When you take a chunk of coal or a pool of oil or a burp of natural gas and you light it on fire, what you are actually doing is that is a very rapid process. You are taking something and instantly releasing all of its carbon dioxide at once. That is also a short-term exchange. That short-term exchange is actually what causes increases in carbon dioxide concentration. But why is that? Why is it that that short-term exchange does that? Well, here's why. The reason why is because what you're actually doing, if left alone, that stuff would have actually been a long-term process, which I'm going to talk about in the next two videos. But by burning it, you have made it all happen at once. You have made it all happen at once. So that being said, in our next video, we are going to talk about the long-term process. Some other short-term processes, just to do a little bit more justice. So fossil fuel emissions are a short-term process because taking fossil fuels and burning them happens really quickly. People breathing in oxygen and exhaling carbon dioxide, that is another short-term process. Plants dying and decaying, over here actually, I lied, over here, also release carbon. Photosynthesis absorbs carbon. Agriculture absorbs and then absorbs carbon and releases oxygen. There's all these different components, and you don't have to memorize this. But there's a bunch of different legs to short-term carbon cycles. Now, most of these legs are actually a part of a full, complete circle, such as over here, photosynthesis removes carbon dioxide from the atmosphere. Eventually, that tree dies, releases carbon back into the atmosphere. Wash, rinse, and repeat. However, fossil fuel emissions are the only process that doesn't have another natural short-term process to counteract them. And the reason why is because these emissions are actually supposed to be a part of the long-term cycle. Once again, if left alone, that process would take a lot longer. How much longer? We'll talk about that in the next two videos.